There is a potential problem with sharing a circuit between a microwave and a telephone outlet. Microwaves can generate electrical noise. This noise can interfere with the operation of telephones. This interference is more likely if the telephone is located close to the microwave. The National Electrical Code, NEC, doesn't specifically prohibit connecting a telephone outlet to the same circuit as a microwave. However, it recommends connecting microwave ovens to a separate circuit. Microwaves draw a significant amount of current. This high current draw can cause voltage drops in the circuit. Voltage drops can interfere with the operation of other appliances, including telephones. If you're concerned about potential interference, connect the telephone outlet to a different circuit. You can also try to locate the telephone as far away from the microwave as possible. The NEC requires that convenience outlets in kitchens be supplied by at least 2 separate 20-ampere circuits. This requirement ensures enough power for typical kitchen appliances. Connecting the telephone outlet to one of the kitchen convenience circuits puts it on the same circuit as other appliances. These appliances might include the refrigerator, oven, and dishwasher. The shared connection could overload the circuit and cause it to trip. It is best to connect the telephone outlet to a dedicated circuit for all of these reasons. A dedicated circuit helps ensure the telephone operates properly. It also prevents the circuit from being overloaded. A dedicated circuit minimizes the risk of electrical noise interference from the microwave. Here's a breakdown of the key considerations. Firstly, electrical interference. Microwaves generate electrical noise when operating. This noise can bleed into the electrical system. It affects nearby devices, especially sensitive electronics like telephones. Secondly, voltage drops. Microwaves draw a substantial amount of current, particularly when starting up. This sudden surge in current can cause a temporary drop in voltage on the circuit. This voltage drop can affect the performance of other devices connected to the same circuit, including telephones, potentially causing them to malfunction or experience poor audio quality. Thirdly, NEC recommendations. While not a strict requirement, the NEC suggests providing a dedicated circuit for microwave ovens. This recommendation is based on the understanding that microwaves are high-demand appliances. They are prone to causing electrical disturbances. Fourthly, kitchen circuit requirements. The NEC has specific requirements for kitchen circuits to ensure adequate power for various appliances. These requirements, outlined in sections like 210.52. The 2 aim to prevent overloading and ensure safe operation of kitchen appliances. Fifthly, dedicated circuit benefits. A dedicated circuit for the telephone offers several benefits. It isolates the telephone from potential electrical noise generated by the microwave. It prevents voltage drops from affecting the telephone's performance. It minimizes the risk of overloading the circuit. Sixthly, alternative solutions. If a dedicated circuit isn't feasible, consider these alternatives. 1. Relocate the telephone as far away from the microwave as possible. 2. Use a telephone with built-in noise filtering. 3. Ensure the microwave is properly grounded. Seventhly, grounding and bonding. Proper grounding and bonding are crucial for minimizing electrical noise. Ensure that all electrical boxes and appliances are properly grounded according to the NEC. This helps to create a low impedance path for fault currents, reducing the potential for electrical noise to propagate through the system. Eighthly, surge protection. Consider using surge protectors on both the microwave and the telephone. Surge protectors help to protect against voltage spikes and surges. These spikes can damage sensitive electronics and potentially contribute to electrical noise. Ninthly, wiring quality. Ensure that the wiring is in good condition. Use the correct gauge of wire for the circuit. Loose connections and damaged wiring can increase electrical noise and voltage drops. Tenthly, professional evaluation. If you're unsure about the best way to wire the telephone outlet, consult with a qualified electrician. An electrician can assess your specific situation. They can recommend the most appropriate solution based on your needs and the requirements of the NEC. Considering these factors will help you make an informed decision about whether to connect the telephone outlet to the same circuit as the microwave. It will help you to minimize potential problems. A dedicated circuit offers the best protection against electrical interference and voltage drops. It ensures reliable operation of the telephone. However, if a dedicated circuit isn't feasible, alternative solutions can help to mitigate the risks. It is worth considering the use of shielded cables too. Shielded cables can help to reduce electromagnetic interference. They have a layer of conductive material, usually a metallic braid or a foil. This layer surrounds the inner conductors. This shield helps to block external electromagnetic fields from interfering with the signal carried by the cable. Similarly, it prevents the signal from the cable from radiating outwards and interfering with other devices. When used for telephone wiring, shielded cables can help to minimize interference from nearby appliances, such as microwaves. This is especially important if the telephone is located close to the microwave. The shielding effectiveness depends on several factors, including the type of shielding material, the frequency of the interference, and the quality of the cable. Properly terminated shielded cables are more effective than unshielded cables in reducing interference. Additionally, consider using a line filter for the telephone. A line filter is an electronic circuit designed to block unwanted noise and interference from the telephone line. It typically consists of inductors and capacitors that filter out high-frequency signals. These unwanted signals can cause static, hum, or other types of interference on the telephone line. Line filters are available in various forms, including plug-in filters, inline filters, and built-in filters. They are often used in situations where the telephone line is exposed to electrical noise from nearby appliances or equipment. When selecting a line filter, it's important to choose one that is compatible with the telephone system. It should also be designed to filter out the specific frequencies of noise that are causing the interference. The effectiveness of a line filter depends on the severity of the interference and the quality of the filter. In some cases, a line filter may not be sufficient to eliminate all of the noise. However, it can significantly reduce the level of interference and improve the clarity of the telephone signal. Regarding microwave ovens specifically, they operate by generating high-frequency electromagnetic radiation. This radiation heats the food. However, some of this radiation can leak out of the oven. This leakage can cause interference with other electronic devices. Microwave ovens are designed to minimize radiation leakage. However, some leakage is inevitable. The amount of leakage depends on the quality of the oven and its age. Over time, the seals around the door of the microwave can wear out. This increases the amount of radiation leakage. If you suspect that your microwave oven is leaking excessive radiation, it's important to have it inspected by a qualified technician. They can measure the radiation levels and determine if the oven needs to be repaired or replaced. In addition to radiation leakage, microwave ovens can also generate electrical noise that can interfere with other devices. This noise can be conducted through the power lines or irradiated through the air. To minimize electrical noise from a microwave oven, it's important to ensure that it is properly grounded and that the power cord is in good condition. You can also try using a power line filter to block noise from the microwave oven from entering the electrical system. When installing a telephone outlet, it's important to follow the NEC guidelines for wiring and grounding. The NEC specifies the type of wire to use, the size of the circuit breaker, and the grounding requirements. Following these guidelines ensures the electrical system is safe and reliable. It minimizes the risk of electrical shock or fire. The NEC also specifies the location of telephone outlets. Telephone outlets must be installed in accessible locations and must be protected from physical damage. They should also be installed away from sources of moisture, such as sinks and showers. When wiring a telephone outlet, it's important to use the correct wiring method. The NEC specifies the wiring methods that are permitted for telephone outlets. The wiring method must be appropriate for the type of construction and the environment in which the outlet is installed. It's also important to use the correct connectors and terminals. The connectors and terminals must be compatible with the wire. They must be properly installed to ensure a secure electrical connection. If you're not comfortable working with electricity, it's best to hire a qualified electrician to install the telephone outlet. An electrician can ensure that the outlet is installed safely and correctly. It's crucial to consider the impact on other devices connected to the same circuit when adding a new device to an existing electrical circuit. Every electrical device draws a certain amount of current. The total current drawn by all devices on the circuit must not exceed the circuit's capacity. If the total current exceeds the circuit's capacity, the circuit breaker will trip. This will interrupt the power supply. To avoid overloading a circuit, it's important to calculate the total current drawn by all devices on the circuit. You can find the current rating of each device on its nameplate or in its instruction manual. Add up the current ratings of all devices to determine the total current. If the total current exceeds the circuit's capacity, you'll need to either reduce the number of devices on the circuit or install a new circuit with a higher capacity. In addition to the current rating, it's also important to consider the voltage rating of the circuit. The voltage rating of the circuit must be compatible with the voltage rating of the devices connected to it. In the United States, most household circuits are rated at 120 volts. However, some appliances, such as electric stoves and clothes dryers, require 240 volts. Connecting a 120-volt device to a 240-volt circuit will damage the device. Connecting a 240-volt device to a 120-volt circuit will not provide enough power for the device to operate properly. Before connecting a device to an electrical circuit, always check the voltage rating of the device and the voltage rating of the circuit. If you're not sure about the voltage ratings, consult with a qualified electrician. Regarding power quality issues, they can affect the performance of electronic devices. Power quality refers to the stability and reliability of the electrical power supply. Poor power quality can manifest in several ways, including voltage sags, voltage surges, and harmonic distortion. Voltage sags are temporary decreases in voltage. Voltage surges are temporary increases in voltage. Harmonic distortion is the presence of unwanted frequencies in the electrical signal. Voltage sags can cause electronic devices to malfunction or shut down. Voltage surges can damage sensitive electronic components. Harmonic distortion can cause electronic devices to overheat and fail prematurely. There are several steps you can take to improve power quality. These steps include installing surge protectors, using power line filters, and ensuring that the electrical system is properly grounded. Surge protectors protect against voltage surges by diverting excess voltage away from electronic devices. Power line filters block unwanted noise and interference from the electrical signal. Proper grounding helps to stabilize the voltage and reduce electrical noise. In some cases, it may be necessary to install a dedicated power conditioner to improve power quality. A power conditioner is a device that regulates the voltage and filters out noise and interference. Power conditioners are typically used in sensitive electronic equipment, such as computers and audio equipment. When troubleshooting electrical problems, it's important to follow a systematic approach. Start by identifying the symptoms of the problem. Then, gather information about the electrical system and the devices that are affected. Next, use a multimeter to test the voltage, current, and resistance of the circuit. Finally, based on your findings, take corrective action to resolve the problem. If you are not comfortable working with electricity, it's best to hire a qualified electrician to troubleshoot the problem. An electrician has the knowledge and experience to safely and effectively diagnose and repair electrical problems. When working with electricity, it's always important to follow safety precautions. These precautions include wearing appropriate safety gear such as gloves and eye protection. To energize the circuit before working on it, use insulated tools. Never work on electrical equipment in wet conditions. If you're not sure how to safely work with electricity, consult with a qualified electrician. Remember to always prioritize safety when dealing with electrical systems.